Thank you for coming. Let's get a little logistics out of the way to start to kick this off. You may have noticed in the session catalog, this is a -S session. If you haven't figured out by now, -S means sponsored. So before you run, do not worry. While this is a sponsored session by Trend Micro, I am not here to talk about product. I am not here to talk sales pitch. I'm here to teach you how to put together the various pieces that are already available in your AWS account from AWS, some extra white paper, some open source stuff, to put that together to make security make sense, right? To put all these pieces together, okay? My name is Mark Nunnikoven. I am the VP of Cloud Research at Trend Micro. I'm also an AWS community hero. As part of that is giving talks like this and trying to help people understand what's going on with security. I have been a security practitioner for a very, very long time. I like to think I'm not as cynical and as grumpy as my colleagues in the security community, but I will apologize in advance. Some of that cynicism will pop out during this talk, and I will try to walk it back as it happens. But let's start off with something that you may or may not agree with. The cloud simplifies security. Ooh, I got a big gasp already. I love it. Yes. Okay. I will walk you through why I believe this, and we'll see if maybe instead of a gasp, we get agreement afterwards. But I think it truly does simplify it. As long as you understand how it works, compared to traditional environments, it's far simpler. And depending maybe on how much you listen for the next 60 minutes. Okay? It all starts with understanding what our goal is in cybersecurity. Now, if I asked a room of practitioners, and maybe that's a good way to pause for a second, how many in this room are security practitioners? Like the majority of your job is security. Awesome. So we're about 50-50. This is good. We're going to get a little confrontation, make the talk a little bit better. So if you ask the half of the room that are security practitioners, you're probably going to get a rather long-winded answer around the confidentiality, the integrity, and the availability of information. While that's correct, while that does actually meet the understanding and the definition of security, I think there's a far better way to phrase it. I think it's a far more approachable way to phrase it. It's very, very simple. It's make sure that whatever you're building works as intended and only as intended. Now, there's a lot of follow-on effects from that, but an easy example, how many folks are developers, mainly builders in their role? A few of you? Okay, so if I ask the developers when something is done, most of the time they're going to say if I'm writing a function that spits out a TPS report, whenever I run that function and get a report, that's done, right? We've got maybe a little documentation, tiny bit, hopefully developers, and maybe a unit test. As long as I run it and I get a report, I'm finished. The security answer to that is, what else can I make that function do? Can I make it spit out other information instead of whatever the heck a TPS report is, right? So it's asking that question of not just does it do its job, is that the only thing it's capable of doing? Now, the other advantage of this definition or this goal is that you cannot do it alone as a security team. You have to be working with the rest of the team that is building a solution. I was waiting for somebody to gasp or be like, what? Because most of the time, that is not how you would describe the average security team. The average security team you will see at the start of a project and like the day before it goes live. At the start of the project, they will tell you a whole bunch of stuff that thou must do. At the end of the project, they will just smack their head against the wall and go, you didn't do any of it, but fine, you can go live on Monday anyway. It is not a productive relationship for either side of the equation, right? So I like this goal. Keep this in mind as we move forward. Fundamental thing to understand in AWS is the shared responsibility model. Hopefully that is not a new term to anybody. Has anybody not heard that term before, the shared responsibility model? It's a safe space. You can raise your hand. One person? Okay, fair, good. So real quick, we'll go through it. Basically what it does is defines 6 major areas where work has to happen basically each day, either operational or security, just to keep the lights on, to keep things working. Right? We cross it from physical infrastructure, virtualization, OS, app, and data. In a traditional on-premises environment, you're responsible for it all. Right? Normally that's divided among teams. You've got teams that worry about the fact that you own the rights to be in the data center, that the data center has power, that it has connectivity, all that kind of stuff, right? When you move into the AWS cloud, you now start to share these responsibilities. And where that division of sharing is depends on what service you're using. It's critical you understand that line. If we move into an infrastructure level service, so something like EC2, right off the bat, half of the responsibilities are pushed to AWS. So you know when you fire up an instance in EC2, they give you the keys to the operating system. So if you fire up a new Windows instance, you now have administrator access to that instance. You can do whatever you want to that instance. It is your responsibility. You can set the administrator password to be password if you so choose. Pro tip, don't do that. That's dumb. But you could do it because it's your responsibility. But you will never see access to the virtualization layer. You know, all the great stuff Peter was talking about on Monday about the Nitro layer, you never see it, right? Because it's AWS's responsibility. As you move through the various services, going container or PaaS level services all the way over to abstract level services, AWS does more and more of the work. So if we take an example of something in an abstract category, S3. S3 is a huge pet peeve of mine. It's sort of a trigger word at this point because people keep leaving buckets open, or I should rephrase that, people keep making buckets open. For the record, they start completely locked down to the entity that created them. Yet there is now, as of this week, eight major features or services that will help prevent that from happening. Okay? But it's of understanding the S3 bucket sort of exposure is a great example of people not understanding this model. According to this model, when it comes to S3, you are responsible for the data and then the service configuration. So am I okay putting this data into my S3 bucket? And then are the permissions correctly configured? And how have I set up the data access points and various things, right? Very little responsibility compared to an EC2 instance where you are responsible for maintaining it, patching it, creating users, installing software, all that kind of stuff, right? So this makes sense. The more you go towards the right to the abstract level, the less you have to do. That, right off the bat, is a security win, okay? But being a good security guy, I don't just take anybody at their word, right? I have earned my tinfoil hat and the gray and white in my beard and hair. You will need to verify what is happening. That's where AWS compliance programs come into play. So you can go to aws.amazon.com/compliance. You will see a monstrous amount of logo soup, a whole bunch of logos that mean nothing to almost nobody. But for that one person that looks for that logo, it means the world. Because what it is that a third party, normally one of the big 4 or 5 auditors around the world, have gone to AWS, they have monitored their practices and processes, and they have verified that they are holding up their end of the shared responsibility model. So you don't just blindly trust them. Now you've got validation that they are actually doing what they say they're doing. They're securing their side of things. So this model is how everything works. And we've talked about it a bit, but basically if you use the highly scientific non-numerical chart, you will realize that in white, your responsibility falls the more you move over towards abstract level services, right? The closer you get to S3 or Route 53 or Lambda, the less you have to do, the more AWS does. I am fundamentally lazy. I like when people do more work and I do less. That is a good thing. From a security perspective, that means your already limited resources can focus on a narrower scope of work and hopefully do a better job. Because I've yet to meet a security team around the world who wasn't absolutely overwhelmed and in constant firefighting mode. So the shared responsibility model gives us the ability to put some of that load onto AWS. And I will tell you right now, they do it at a world-class level. And if you think you can do it better than them, you are slightly delusional. Hopefully in a good way, but still, it's, but there are still people who don't understand this model and still hold to it and say, well, we can do a better job of securing the infrastructure. We're going to stay more on-prem for sensitive workloads. Not true. AWS will do a better job than you, and if you can get them to do it even at the same level, why wouldn't you? So that leads us to another question. What's stopping us from having good, secure, resilient systems? Who are we up against here? Now, if we start to ask around the room, we're probably going to get answers like hackers. Hackers, always in basements, always in dimly lit places, always with a hoodie that is dark blue or black, and for some inexplicable reason, fingerless gloves. Don't know, just how it is. There's actually, in the security community, a fun project underway to get better stock art for hackers, and it has gone nowhere. Nobody's come up with anything better. But here's the thing. When it comes to hackers, when it comes to cyber criminals, yes, you are going to have challenges, but they are not your number one issue. Okay? They are out for profit. It is an amazingly and intriguing world that cyber criminals have created with tiers of businesses. If you want to see amazing market analytics, look at some of the cybercrime reports that have been published by research firms around the world. It is amazing how much they fine-tune phishing attacks, how much they do phone scams. It's just absolutely crazy. But hackers are a concern, but they're not our top concern. Maybe you'll go with one of my favorites, nation states. Anybody worried about nation-state attacks against your infrastructure? Awesome. Do you all also work for a nation-state? Because if you don't, and I mean this very, very seriously, if you don't have a chance. By definition, a nation-state has almost unlimited resources, and if they are determined to get into your system, they're going to get into your system because you do not have unlimited resources to defend against them. Sounds really bad from a security perspective to say that. That's the reality. So why would you spend a huge amount of resources against an attacker that you never have a chance of winning against, right? You can practice basketball all you want. You are not going to beat LeBron, right? You are not going to beat MJ back in the day. Just accept it. Easier to move on. Maybe you're going to talk about insider threats. Okay? Love insider threats. Everyone's always concerned about insider threats. Insider threats are not a technology problem. There are good practices you can do to reduce the challenges you may have from the inside. Realistically, it's an HR and culture problem, right? We've seen that even at Trend Micro. We've had issues inside, or we had one recently. But it's culture and challenges. And at the end of the day, people need to have access to do their work, right? You have to have access to certain systems to complete your work. Again, not your number one problem. If you're wondering what this reference is, search for Quinnypig, Corey Quinn on Twitter. He actually ran a great campaign to donate to charity on this, but it has been a long-standing feud within the AWS Cloud community of whether an AMI, an Amazon Machine Image, is an AMI or an AMI. Nerd debates are fun. You know, VI versus Emacs, tabs versus spaces, AMI versus AMI. But insider threats, not nearly the concern we are. What do we actually need to concern ourselves with? It's actually really, really simple. Mistakes. Mistakes are the absolute number one problem that we all face today. That should be the primary focus of your security program, is to cut down on mistakes. The beauty of the AWS Cloud is that we, as builders, now have access to an insane amount of power, right? We have 175 services in the AWS Cloud. With one CloudFormation script, I can stand up the equivalent of a data center for an entire enterprise, right? One script, launch it, good. Now I'm also responsible for my areas of the shared responsibility model in there. We talked about the S3 buckets. Every S3 bucket media headline you've seen, so major companies, political parties, millions and millions and millions of personal records breached over the last few years because somebody made a mistake. That's it. A simple mistake. The good news is, if we focus on that, we can cut that down. So we understand that. We know our goal. Make sure that our systems work as intended, only as intended. Our largest risk, the number one threat in our model, is ourselves making simple mistakes or misconfigurations. So that's the groundwork. Okay? That's what we're up against. That's what our goal is. That's our largest risk. With that understood, now we can start to walk through to see what we can do to build out a security practice to actually integrate security from various AWS tools. So the good news is you don't have to start from scratch. Okay? There are a number of resources available from AWS to help bring you up to speed. The first of those is called the Cloud Adoption Framework. Has everybody read the Cloud Adoption Framework? A couple people? Those people who have read it have had at least one fantastic night of sleep, I guarantee it. It is a 50-some page white paper available in PDF. It's available. It came out of the AWS Professional Services Organization, of their experience helping organizations migrate into the cloud. It is absolutely dry reading, but it is critical. What it does is it breaks the process of moving into the cloud down into what they call perspectives. So they have 6 perspectives. 3 of them are on the softer side, so the business, people, and governance. 3 of them are on the more technical side, platform, security, and operations. And for each of these perspectives, the framework helps you walk through engaging stakeholders in the business, mapping out your current workflows for what your business is trying to accomplish, and then predicting how things will change as you adjust the technology and start to embrace the cultural requirements around building in the AWS cloud. And the output of the Cloud Adoption Framework is an action plan. This is a map that will help you take your existing infrastructure, your existing business processes, and move them into the AWS cloud. So we heard on Tuesday Andy Jassy talking about transformation, right, with a lot of really semi-questionable music choices. But he was talking about transformation, and it's funny because people always go back and be like, no, this is a technology thing. It's not. You can take what you're doing today and just drop it into the AWS cloud, and it will work. But you are leaving so much power and capability on the table that it's almost a crime. Right? It's like buying an F1 supercar and all you're doing is driving to the corner store to grab a snack. Like, it just doesn't make sense. It'll work, you'll get there, but you're probably going to get a ticket for one thing and you'll look ridiculous doing it. Okay? The Cloud Adoption Framework helps you build out a plan for digital transformation. So it's worth reading through those 50 pages and mapping that out and working through your business to understand, very simple example, if you have a team that's responsible for on-premises infrastructure on the technology side, what are they doing when you move to the cloud and AWS provides your infrastructure now? Right? You may need to retrain, you may need to reorganize. There's a whole bunch of stuff. That's where the Cloud Adoption Framework jumps into play. Another one that you're freely available from AWS is called the Well-Architected Framework. It has 5 pillars: operational excellence, security, reliability, performance, efficiency, and cost optimization. The idea here is targeted at technical teams in order to help you understand how to make smart trade-offs. Right? You can't have everything. I wish we could. You can have a lot more when you're building the AWS cloud, but at some point you need to figure out, do I use Amazon Aurora for a database, or do I use RDS, or do I roll my own on EC2? Easy tip, never roll your own on EC2. Right? But how do you choose between RDS and Aurora? The well-architected framework helps you understand those choices and how to constantly reevaluate those choices. Freely available from AWS, there's even a service, and I say service with big quotes, to help you walk through the well-architected framework. It's called the well-architected tool. Essentially what it is a big questionnaire. That's why I use quotes around service. It's a big questionnaire that lets you save your answers. I'm not sure how that escalates to full service capability, but it is a very handy tool. So the output here is constant reevaluation of your architecture to make sure that what you're building aligns with your business goals. Another thing I want to call out is modern application design or development. It's a concept from AWS that says there are 6 attributes for a modern app: secure, resilient, elastic, modular, automated, and Lord knows what interoperable means, but it's there. Normally they're referring to data in and out. Doesn't always apply. But essentially it's the acknowledgement that you have a bunch of applications already in play unless you started your business today. So if you didn't start business today, you already have stuff that you have to deal with. So there are 4 paths to move to the cloud. Normally you go through 3 or 4 of them in a sequence. You can rehost, replatform, refactor, or reinvent. Essentially rehosting, it just means picking it up, dropping it in AWS. Replatforming is taking your Windows 2008 based application and moving to Windows in 2016. Same refactoring is starting to adjust to moving out of a relational database into something like DynamoDB. And reinvent is a complete rewrite from the ground up. But again, modern application design or development helps you with a bunch of resources freely available from AWS to figure out how to break these things down to map out a path, right? Why stumble through the dark on your own? They've already mapped it out for you. And the last thing, very specific to security, is the CIS AWS Foundations. This essentially ends up being prescriptive guidance. It's basically a giant checklist. It is a bunch of very simple baseline activities. So have I enabled encryption on all my databases? Do I have a strong password policy on IAM, identity and access management? The good news here is the AWS Security Hub service, which is generally available to everybody, has a bunch of check marks that will automatically compare what you're doing to the baseline, to the foundational framework here. So you can actually just get a report how good you are with these basics. So there's 4 things that can help you right from AWS walk down this path. Now I know you're probably thinking okay, we've been talking for 20 minutes, we haven't gotten into any technology at all yet, but I think it's important to get that baseline to understand what you're dealing with, because security is not an isolated activity. Security is really about building well, building resilient applications. We in security have the exact same goal as your business, as your development teams. We just talk about things in a really awkward and confusing way, okay? So we've got the baseline here, we understand. So let's look at sort of the 6 key questions from a security perspective. And I like to break it down to that. If you're trying to secure your development or your environment, if you're trying to secure a new application, here are the 6 questions that we're going to work through. And we'll start with 1. And the first thing is, what happened? If something went wrong, your first question is generally, what happened? In the security world, this comes down to auditing. Are there any auditors in the room? They rarely, oh, right on. I was going to say, they rarely admit it if they are in the room. Wonderful, wonderful people. Very exciting. No, seriously. The challenge, auditing gets a really bad name because most people don't worry about audits until Friday when the auditor shows up on Monday, right? And that's just process, people not understanding how this all fits together. Really fundamentally, auditing is the answer to the question of what happened. And in the AWS cloud, there is one primary service that you want to be investigating. Now, the good news is it's on by default across all your regions on all new accounts. If you have older accounts, you may still have to turn it on. That's AWS CloudTrail. AWS CloudTrail basically gives you a list of what happened in your account and who or what made that thing happen. Okay? It is extremely dry and boring to look at, but if you are trying to investigate what went on, it is priceless information. So in here is included a signed audit trail of the vast majority of API calls that happen in your account. So whether somebody is logged into the web browser, using the CLI, using an SDK, or using a third-party tool, if there is an action taken in your AWS account, there is a signed trail in CloudTrail that says at 11:40, Mark made a call and spun up 8 new instances in EC2, and here are the configuration of those instances. Right? So this is just a trail of breadcrumbs of what has been happening in your account and a nice interface to manage all of that data. There are a ton of security services and a ton of things that you'll see later on in here that pull information from CloudTrail. It's sort of the single source of truth that's going on. As I mentioned, it is on by default. Now, the biggest thing to know here is that CloudTrail is not instant. It takes a while. There is no guaranteed SLA for CloudTrail. The ballpark experience answer is expect things to show up in CloudTrail 2 to 4 minutes after they've actually happened. Okay, now that's an important distinction, which is why we've put this under auditing. Because if you're trying to react to something happening in your account, CloudTrail is not a good source to react from because it happened 2 to 4 minutes ago. If you're responding to a cybersecurity incident, that is 2 to 4 minutes too late. Okay? But if you're just doing maintenance, if you're just seeing the state of your systems, 2 to 4 minutes is more than fast enough, okay? So that's the core service when it comes to what happened. Our next key question is, who's there? Who's doing what in our environment? And this, for security, comes down to the concept of identity, okay? It is a huge practice within itself. Everybody has struggled with the accuracy of your identity system, your Active Directory most of the time in your enterprise. I had it here at registration for reInvent. I had 2 records. There was 2 of me. And we had to figure out, okay, what attributes needed to be merged across the records, right? That happens in every organization all the time. But from a security perspective, you need to know who's doing what. Identity is how we get there. There is a core security principle that you need to be aware of and hopefully implement. It is easier than ever to implement, which is awesome, but it's this principle of least privilege. It means that you should be granting only the permissions required to do a task to the person or system doing that task, right? We are all guilty. I won't even ask for a raise of hands unless everybody needs the exercise because I guarantee everyone will have to raise their hand. We have all given somebody way too many permissions just to make it work, right? Just make it work. Just give me full access to everything. That may make it work, but it also creates this gap where you have way too many permissions, and if something happens where your account is compromised or that entity is compromised, that is a security vulnerability. That is an issue that needs to be addressed. The good news here is that we have a fundamental service from AWS. It is one of the very few global services. It does not have a region specific. It has one interface for every account that applies to all regions across. This is AWS Identity and Access Management, or IAM. It allows you to create users and roles as well as permissions. So it helps us answer who are you and what are you allowed to do. Okay? Very easy, very granular. It lets you manage those users and roles. You can assign permissions directly to policies or to roles and users. There are granular permissions available for each service, which lets us use that or apply that principle of least privilege. Now, slight rant. When you look in IAM, there's a list of pre-managed policies. A number of these policies end in 2 horrible, horrible words: full access. Don't use them. If you are in development environment, maybe, but if you want a quick security win, when you go back to your console and log in your production account, if anybody is using a full access policy, I can guarantee you it is almost always wrong. It is too many permissions because it does exactly what it says. It gives you full access. So if you add S3 full access, they can list buckets, they can delete files, they can change versions, they can turn off versioning, they can nuke every single piece of data in your S3 account, right? Normally, that's way too many permissions. But they can be handy to solve the problem of I just need full access, right? So This is also allows you, IAM, to connect to existing identity infrastructures. You don't have to actually create all your users and roles again. You can pull them in from if you have an Active Directory or if you have some other identity source. Makes it really straightforward. But when you're managing these permissions, things can really scale out of control quickly. So if we wanted to give a user access to an S3 bucket, you can just assign a permission to them. You can assign a permission that says, Mark has the ability to read and write to this bucket. You can add a whole bunch of conditions to it if you want. You could say, I just have the ability to write, but the idea is you assign a permission to me. That works for a little while, but it really starts to get unmanageable as you add a few users, because you start just adding more and more permissions and you rarely circle back. So what a really strong strategy is to create roles. Now, roles can be assigned to people, or they can be assigned to things. So you can let an EC2 instance or a server assume a role and give it a set of permissions. Lambda, every time it executes, has a role. So what you do is you set up roles based on desired outcomes for tasks. So if somebody is managing backups, you could have a backup role, right? For somebody who's launching systems, which should only ever be a system, but if you need to launch EC2 instances, you can have an EC2 launch role. Me as a user, I should generally almost have no permissions most of the time, unless I need to assume a role to then take on a task. So my account, Mark, has a bare minimum set of permissions that says I'm allowed to take on other hats. I'm allowed to put on other hats to do tasks. And then you can restrict what those tasks are. And then that way you're only ever managing permissions for the roles, not for the individuals. So if your company scales out from 10 people to 10,000 people, you don't really have to change anything because you've put all the permissions based on workflows instead of people. Right? So eventually you just switch and you can use the new tag-based system. If you are doing this yourself or if you have a team who's doing it, I would strongly recommend Security 316 this week. Bridget Johnson from the AWS team is doing a talk based on how to apply roles and permissions based on tags in the environment, which if you have a big environment, that's the way to go. So the idea here, assigning it to roles really helps things out. And as I said, I actually put that in the notes. See, I thought ahead. There are some extra resources here. You can do Sec 209, which is this week. They have, for Monday and Tuesday, the talks are already up on YouTube. But best to kind of just create a list in your notes and check them out next week. So Sec 209 is the basics of IAM. 316 is the one I just talked about with Bridget. And then there is actually an IAM best practices document online, which is really, really good and talks about these principles. Because identity is the absolute core of everything you're going to do. Right? You need to get this right, and you also need to stay on top of it. I'd say the number one mistake people make is they assign permissions and they never go back and check them. Well, if you remember, our first little topic, our first service was CloudTrail. That's an audit trail of what's actually being used. There's a great way to connect those two to see who's been assigned what permission, and then are they using it or not. And you can have an automated script to do that. I've done a few talks. If you talk to me after, I'll give you the links to that stuff, where you can actually automatically check, Mark has these 10 rights, these 10 permissions. Is he using them? No, he's only using 2. Okay, we'll take the other 8 away, right? So you have to stay on top of it. So let's get a little bit more into the weeds here. Let's talk about how you can possibly protect your network. Because normal network security techniques aren't as directly applicable when it comes to AWS Cloud. Because we've got a lot more flexibility in how we build a network within AWS, right? When you're building a network on premises, you have to build out your core switching infrastructure. You have peering connections to partners or other regional sites. You have upstream connections. You have a whole bunch of infrastructure that you have to worry about. As we know from the shared responsibility model, when we move into AWS, most of that stuff's their responsibility. If you saw Peter DeSantis' talk on Monday, the Monday Night Live, he was talking about the Nitro system that manages networking and compute and storage. That is a software-defined networking layer across the entirety of the AWS cloud. And now we have some services that let us kind of tweak a little bit of it to make our own little slice. And the core unit of that is an Amazon VPC, or a virtual private cloud. It's basically your slice of the AWS cloud, okay? The good news is VPCs are free. There are limits on your accounts, but accounts are also free. And actually, multi-account strategy, there is another super boring white paper on the AWS website about multi-account strategy. But an account is a nice firm boundary that is difficult to cross over between. So if you have different levels of sensitivity and information, accounts are a great way to set it up. It also gives you more access to more VPCs. But your VPC is a virtual private network. It lets you control the routing, the IP space, the subnetting, the access controls between parts of your network. So essentially, you can set up little areas where people can talk to each other, and then who can talk to whom, and centralized services. We now have these things called VPC endpoints, which lets you access AWS services from within your private cloud instead of going out to the internet. That again keeps your network flowing under your control, which means you also get logs on it. And then Private Link is the version of endpoints that let you connect to third-party SaaS providers that are APN partners. And then Direct Connect is the final service that lets you connect back to your on-premise network if you have one. But all these things, so those 3 services under VPC, all let you control networking and set things up. And what you'll find is you'll quickly have a lot of different VPCs. If you find your teams trying to shove everything into one VPC, or 2 or 3 of them, that's probably the wrong approach, okay? We have essentially unlimited capacity within AWS. Use that to your advantage to keep things simple. Last year, AWS announced a new service called Transit Gateway. This solved a long-standing problem of connecting your VPCs together. Now it is very, very simple. And in fact, yesterday, AWS launched a new feature for Transit Gateway called Network Visualizer, which is absolutely fantastic. It's free of charge on top of Transit Gateway. There's a charge for Transit Gateway itself. But essentially, this finally lets you look at a nice little graph of your VPCs, how they've connected together. So you get that overview of what's going on in your network. But this, again, allows us control in here. So if we have multiple VPCs, or if you're going to expand to multiple VPCs soon, you want to be using Transit Gateway. There is another feature called VPC peering. It's an older feature. It lets you make a direct connection between parts of a VPC to another one. Unless you have 1 or 2 peers, you really want to go Transit Gateway. It's worth the extra money to go Transit Gateway because it makes things simpler. And generally, if you can pay a little bit of money to greatly simplify something, that is a huge security win. Okay? So here's a quick example, though, of one thing that you're not covered with AWS services. You're going to have to layer something on. So everything that we have at our disposal with VPCs, with Transit Gateway, essentially boils down to answering the question, is A allowed to talk to B? So if we have one EC2 instance and we have another EC2 instance, all of these things, so routing table controls your basically addressing in your network space. A NACL, which is always just fun to say, is a network access control list. You have security groups, and then you have the Transit Gateway. These essentially answer the question, am I allowed to talk to you? But what they don't answer is, what are you saying? Right? So you allow something through a security group, that means those 2 points can communicate, but it does not verify what is being communicated. That's where an extra technology called an intrusion prevention system comes into play, because that looks at the packets that are being sent between 2 places and verifies whether they are malicious, whether they are properly formed, that kind of thing. So all of the pieces from AWS help us set up who's allowed to talk to who or whom. And then the IPS and intrusion prevention says, what are they saying? And from security, both of those are very, very important, okay? But unfortunately, you have to go to either an APN partner or an open source tool to set up an IPS. So let's move up. Let's talk about compute, because a lot of us, that's where we focus, that's where we start. And in AWS, we have a lot of options. Compute services let us run code somewhere in the cloud. The question is where and how. So what we're going to do is we're going to start by looking at where in the shared responsibility model the various compute services sit. So we have the traditional EC2. This is, give me a server. Windows, Linux, I want traditional virtual machine, right? We call it an instance in AWS parlance. When it comes to the shared responsibility model, it's a 50-50 split. I get access to the OS, and it is mine. I can do whatever I'd like to it, right? When we move up, we go to Amazon ECS. This is the Elastic Container Host. How many folks are using containers in their deployments today? Everybody loves a buzzword, right? Containers, very useful if you know what they are. From a security perspective, the number one thing you need to worry about is the definition of a container is a compute structure that is loosely isolated from other compute running on the host, which means your containers are not on their own. They can talk to the neighbors. And we've seen several attacks where people are trying to go from one container to another on a host. ECS is the container service from AWS. It is also a full infrastructure service because you have access to the operating system. You are responsible for patching it, for setting up accounts. A lot of that is taken care of for you as part of ECS, but it's just done for you. It is not taken over. It's not managed for you. So you have to treat ECS hosts just like you would EC2. Okay, that's an important distinction. If we move over into container world, AWS Fargate, Fantastic way of running containers without worrying about that infrastructure. The funny thing is, underneath AWS Fargate is a very, very large ECS deployment. The beauty of this, and it's a great illustration of the shared responsibility model, is that that is AWS's ECS deployment. So I don't care how they set it up, right? As a user, you just say, here's my container, I need this much compute power, and I need this much network capacity, and they take care of fulfilling all of that for us. So when it comes to the shared responsibility model, I need to worry about the application running in the container and the data that it's processing, and then the configuration of Fargate as always. And then finally, we have Lambda, everybody's favorite because it's awesome. It is all the way over on an abstract level service. So you need to worry about the data in that service, which is your code. Do you have good code quality? We'll cover that in a second. So these are the main compute services across AWS and how they break down in the responsibility model. Where most security issues pop up is not understanding this alignment, right? Especially for ECS. It is terrifying the amount of people I talk to who are running ECS at scale that have no idea they are responsible for the operating system that runs ECS, okay? Once you got this down, and the slides will be available afterwards, and I'm auto-tweeting a bunch of them as well, just to make it easier for you guys, because I know you like the slightly skewed angle from the slides. On a side note, if anyone's here and wants to participate in the Builder Fair next year, which is like mini science projects, that would be a great project, to automatically unskew slide shots from talks like this and present them in a straight manner and nice and cropped. Be really cool. So if we look at these, now let's talk about what we want to do from a security perspective. We know our responsibility, so let's start with ECS and EC2. First thing we need to do is harden the OS. Hardening the OS means turning off accounts that aren't used. It means disabling services that aren't used. It means keeping it up to date, right? It means locking it down so that it's only doing what it absolutely needs to do. You would be utterly baffled at the amount of things that go on behind the scenes in an operating system just because, right? And a lot of those aren't required for your task that you are trying to accomplish. So hardening it, there are guides for all the major OSs available. If you use some of the AMIs in the marketplace, either community or managed by AWS, they've done a good job at sort of pre-hardening a bunch of stuff. ECS is a good example. The OS on ECS is already locked down quite a bit, which is good, but there's still tweaking that you can do. You also want to install third-party controls to give you better visibility. This is where things like anti-malware, like intrusion prevention, like integrity monitoring, application control, extra tools in the OS that, or added to the OS that will help you make sure that that thing is only doing what you want it to do, right? That's all these security controls are designed to do, is to make sure that you're still on task. And then the final area here is that, and this was where I'm waiting for somebody else to gasp on the security side, you should never patch or log into production systems in AWS. Ever. Saying that, you're still going to do it because it takes a really long time to get people out of the cultural habit. The reason being is you want to fix the problem upstream. You have unlimited capacity when it comes to AWS. So in the olden days, and I was there, I'm saying that self-deprecatingly, we used to have a rack of servers, and I could tell you, I have 7 servers. I cannot afford for 7 of them to go down. If I need to patch, you patch them one at a time and try to keep that going. Right? You've heard Werner talk about it for years, about pets versus cattle. And then my friend Ben Kehoe is very much into the serverless world. He works for iRobot. He was talking about we're moving into Lambda, which is actually roaches, not pets, which I just thought, like, okay, that analogy's done. We need to figure out something better. But the idea in an on-premise environment was that we only had a certain amount of boxes, so you had to patch them, and you had to take a risk of whether that patch would work, and you had to keep production up and running. When it comes to AWS, if I want 1,000 instances, I'll just spin up 1,000 instances. If I want 1,000 more, I'll make a second API call to spin up 1,000 more. So we have this concept of a blue-green deployment, which is you spin up a whole bunch of new ones, test them to make sure they work, and then switch traffic over to the new ones. That is how you should be doing patching. You patch upstream to the base image, not to production. From a security side of point of view, that's a huge win because production is always stable, right? If there's an issue, you fix it once and then redeploy. And when you verify that deployment, you switch things over, as opposed to manually logging into systems and making changes. Because A, someone's going to make a mistake, which we know is our #1 problem. And B, somebody's going to forget to fix that later, so when you do redeploy, the same mistake's going to pop up again. I don't like fixing the same mistake repeatedly. I don't think you guys do either. So don't log in, don't patch to production. If you can, fix it upstream. On the serverless side, and so AWS Lambda and on containers with Fargate, code quality is your number one problem. Okay? Node.js, any Node.js developers in the room? Damn it. Okay. I'll be nice. So Node.js is notorious for when you spin it up and add a new import, you do not just import one thing. So a friend of mine, Brian Vermeer from Snyk, they do open source security and vulnerability analysis. He had a great example where he used a Node.js application, so JavaScript-based application. One import and 224 lines of code turned into 460,000 lines of code in production. Because to make it easier for the developer, when they did one import to pull in a popular library, it pulled in a bunch of libraries, which pulled in a bunch of libraries, which pulled in a bunch of libraries, which in an ideal world would all be well written and secure. But at the end of the day, that's running in your environment. It's your code. You're responsible for it, right? So security ends up being a code quality issue. That's your number one focus when it comes to Fargate, when it comes to Lambda, because everything else has been ceded to AWS as part of their area of the shared responsibility model. You can add some security controls in here, like real-time application protection. That integrates with your code to look for things like SQL injection. Based on behavioral analytics, you can do file checking, things like that. There are some things you can do here. And then dependency verification. We talked about that a little bit there. You want to make sure when your code's pulling in other code that code is good. As a developer myself, it's great when I can rely on somebody else's work, but it is literally a random username from GitHub. Are you going to base your business on the validity of that person's work? You should be doing some extra checking here, right? Don't just blindly trust. So across all of these, there are some commonalities. We already talked about fixing issues in the build pipeline, doing those blue-green deployments. There are some great resources on AWS's website about how to do blue-green deployments and how to manage that and how to build out a build pipeline that includes security. Also, you want to make sure that all of your security controls are automated with all of this stuff. You don't want to have to manually do anything ever. And the security testing and verifying is just another part of code testing. So if I'm writing an application, I'm normally writing unit tests to make sure that my code does the functions operate the way they are supposed to. I normally run integration tests to make sure that the whole of the system works together. Security for a very long time has not been included in testing. We do pen tests occasionally, which is where you have a third party try to attack your system. But the vast majority of organizations box in pen tests so much, they go, well, you can't attack production on Friday night. You have to attack it between Monday of 9 a.m. and noon, which means your results are basically invalid because everybody's expecting it, right? So security testing is a huge thing. And in the AWS cloud, you can do some very basic security testing. So if you've configured a security group around an instance, which is basically a firewall, saying who's allowed to talk to that instance, you can run some very basic tests to see if that's actually applied properly as you're rolling out an application. It's a couple lines of code, a couple lines of script. Why aren't you testing these things? Right? And that starts breaking down that cultural barrier of realizing that security is just part of building well, but it also gives you an extra level of assurance. Is go, yes, we deployed it, and we tested all those routes, we tested all those security controls, and they're all operating correctly, right? You test with a positive and a negative. If you're running something as basic as like an anti-malware control, do you ever drop malware on a system to see if it's detected? You should be, because otherwise you're just blindly trusting somebody. I did say at the start I'm a security person, and I will tell you, I have never been able to shake that I trust no one when it comes to technology. Does not matter. Just do not try, just test it, build it in, and then you get that peace of mind. Also realize that with all of the move in the shared responsibility model towards these abstract services, towards having less infrastructure to touch, cyber criminals and hackers, who, yes, are coming back up as an issue, they are moving where they're attacking to you, the builders. We at Trend Micro Research have seen that significantly in the last 24 months, where instead of attacking systems because they've been well built and well defended, it's far easier to attack you, the developer, because I can probably trick you into installing something. Or just this week, a security research firm found another 2 Python libraries freely available that were stealing SSH keys from developers' workstations. The libraries did what they said they were going to do, but they also harvested SSH keys in the background. Because we're people, we need to do work. We are now the weaker points. Criminals are realizing that, and they're moving things, their attacks towards us. So that means security education. Yes, security education, not awareness, education. So great example. How many people have done an internal security training? Participated or provided one? Okay, so this will be good. We'll take it like 30 seconds just as a reminder. What's the number one thing you should do to prevent yourself from being phished? Anybody, just shout it out. Don't click on links. Thank you. Everyone always gets that in one. Here's the thing, that's wrong. Yeah, and I mean, it's not a baiting question, but honestly, that's wrong. So the reason why is very, very simple. Can anyone tell me the only thing a link was created for? To be clicked on. It's literally its sole purpose in life, is to be clicked on. And we as security people for the last 15 years have told you not to click on them. That doesn't make any sense, right? And then we take it a step further and say, no, you should look at the URL and decide whether that's valid or not. Well, we now have north of 260 different top-level domains, including .wtf, which is my all-time favorite. You can no longer see what's going on. Does anyone work in marketing? Does anyone admit they'll work in marketing? Okay, marketing is the worst. And I say that simply because, have you seen the links they send to customers? They are monstrous, absolutely monstrous with tracking codes. No human can tell me if that's valid or not. So the best way to prevent yourself from being phished is to have an automated system scan your email for known malicious links. So that will take care of a bunch of the junk. But then you as a user, if you click on a link and are then asked to take an action, then your radar should go up. You should be worried then. So if you click on a link and it says log into Google, stop. You're probably trying to be phished. If it says download this file, stop. Make sure you have security controls. Randomly clicking on links, the odds of getting a drive-by attack in your browser for a vulnerability are relatively low. That's where you should have that security system in the background doing it. But that is the number one problem with security training, is that it is so pie-in-the-sky idea that it's not effective, right? And that's just the tip of the iceberg. Do not even get me started on passwords, okay? We've had the math to prove that what we tell you about passwords is wrong for a very, very long time, okay? But this is where we now need to be concerned, because as builders, we're now the weak point, because we're building so much better, which is great, that we're now easier to attack than our systems. So we've got a lot of work to do there, but we need to be aware of it, and that's step one. The other thing is this core principle in AWS that you should always be using systems, not people. So we said don't log into production, because you should have systems that push out new sets of production for you, right? This is the thing. You shouldn't touch a lot of these systems, or a lot of your assets. You should be having systems to do them for you, which is really, really important. So another area we're going to talk about. How do you protect your data? Well, AWS has a host of database services. We saw that from Andy yesterday. We're going to probably hear it from Werner tomorrow. Basically, these are places to put structure accessible data. Things like DynamoDB, DocumentDB, RDS. There is 13 of them officially, and RDS has somehow beaten out the worst names possible by having 7 or 8 names as the official product name. There's Amazon, RDS, Postgres for multi-AZ. It's crazy. The good news is that means you can pick the right database for your data structure, but they all share similar security aspects. You can almost always encrypt the data at rest. The good news here is, unlike in old environments, we do not pay the performance penalty, right? If you ask for a certain amount of I/O performance, you will get it whether it's encrypted or not. AWS just absorbs the hit because it takes computational effort to encrypt your data. We don't have to worry about it anymore. That's great. So you should always be encrypting your data at rest. You should be using IAM permissions to restrict access. Depending on the database you're using, that goes deeper and deeper. So we talked about those permissions at the start. If you're using DynamoDB, you can get down to the individual cell level in the database and set permissions on that. That's awesome, right? That's been extremely difficult to do in the past. It's very, very easy because everything's stitched together in the AWS cloud. And also, you should be backing up everything all the time. And then test that backup. That's the last step that everybody forgets, is they go, oh, I got it all backed up. Have you ever tested it? Well, no, but it's backed up. Yeah, just make sure. Again, you can automate this. Right? Everything in AWS is available through an API call with very few exceptions. Backing something up, spinning it up, and testing it, you can also do fully automatically. Right? And again, less work we have to do, the better. Second class of data ends up being with storage. So here we've got structured accessible data, but normally it's in files. So we talk about things like Elastic Block Store, or EBS. We talk about FSX, which is the file system extensions. S3, all that. You need to know S3 in and out because it is awesome. It is also the foundational point for almost everything you're going to do data-wise in AWS. But we have almost the exact same options, which is great. We can encrypt all the data at rest. We can use IAM permissions to restrict the access. And here, what we're going to do is not back things up because they're almost always backed up as part of the service integrations. We're going to be using lifecycle strategies. The reason why I bring this stuff up, you may be thinking, what does this have to do with security? Your data is what you're protecting. And if you're keeping all of your data forever, that's just increasing the responsibilities you have. So lifecycle strategies are built right into S3, which is great. You can say after 30 days, push this down to a cheaper tier of storage. After 90 days, push it into Glacier. After a year, just delete it. But this is something you need to be aware of just to keep track of what you're trying to protect, right? Again, fantastic tools available to us. So the last question that we're going to ask, right, we've asked about our data, our compute, our network, all that kind of stuff, is any of this working? We've set up all these tests, or we've set up all these controls, we've configured various services. We're not going to trust it. We're going to go into what we call observability. So this ties very deeply into operational tasks, and I'm a firm believer that security is not its own thing, it's an integral part of operations, right? So with Observer, we'll start with traceability actually. So traceability has a technical definition. It is boring. It doesn't make much sense. There is a far simpler way to think about traceability. It is basically, where did this come from, who can access it, and when can they access it, right? That sounds very, very similar to CloudTrail. So we have a ton of traceability already through CloudTrail. But tied to traceability is the concept of observability. Right? And I'm talking that within the operational aspect of rolling out technology. Again, super boring formal definition. Really, observability is what's going on. Right? I don't like formal definitions for most things because they're trying to sound super important. When you can just plain talk is easier. What's going on? Where did it come from? All that. So we have two main services here. AWS X-Ray. Very, very good service that's getting better every day. It was launched last year at re:Invent. It helps you understand the behavior of distributed applications. Okay? Here for key attributes with X-Ray, it's going to give you a cross-service view of your application. So it's going to say your Lambda function called DynamoDB and then called out to QuickSight or into S3 or something like that. So you get this cross-service view, which is great to see that, okay, I have critical data that's here, that's moving from service A to service B to service C, right? Gives you a whole bunch of great usage metrics as well, and telling you the latency between these services and how many failure calls there are and things like that. So from keeping things running, keeping the lights on, it's invaluable as well. But from a security point of view, it's really that visibility that's key. Now there's limited language and service support, but it's getting better all the time. I'm waiting for an announcement this week. I'm sure there will be one. They keep iterating, which is great, but it supports a wide variety of stuff right out of the gate. But this is one to keep your eye on. It wouldn't be the top of my priority to implement simply because it is in its sort of nascent stages, but it's getting better fast, and it solves a real need that nothing else does of actually giving you a visual graph of how your application is calling various services. And then CloudWatch. CloudWatch is not one service, it's actually three under one name. Okay, and a lot of people get lost, especially if you've been using the cloud for a really long time. You think of CloudWatch in one way. If you come to it now, it's kind of confusing to get your head around. But essentially, it does metrics, events, and logs. It is that three services blended in one, but metrics give you basic operational health. So if you're looking at an EC2 instance, how much CPU am I using? How much network's going in and out, right? How much disk space is left? Just some basic operational health things. For logs, it is an actual agent that runs on EC2 or ECS hosts, and it will do system logs as well as application logs, so you can send your custom application logs into CloudWatch logs. It will also pull like Windows events. For Linux, it'll do like SSH logins, all your normal system level stuff, and it pushes it up into the CloudWatch backend. The CloudWatch backend lets you query things over time. It lets you keep your log retention centralized. So if you're sending everything into CloudWatch, you can then manage it in one place and say, okay, I want to keep logs for 30 days. I want to keep everything for 90 days. I want to drop the following stuff. Very, very useful to centralize it. Very, very low cost as well because it backends on S3. And S3 is extremely cheap to keep a very large amount of data. And then the final thing is events. Now, events are something we're going to dive into in the next couple slides a little bit deeper because they are the basically precursor for CloudTrail. So we talked about how CloudTrail keeps an audit log of all the API calls that are going on. CloudTrail or CloudWatch events sends an event as a trigger as soon as that API call is made. So you can think of in your head, CloudWatch is the output after, or CloudTrail, apologies, is the output after CloudWatch events. So a CloudWatch event is fired. There's something magical in the cloud that takes that event and writes it to CloudTrail later. But we have access to the events directly, which means one of the key tenets for a good security practice on AWS, we can start to build off of this, which is automation. We want to do everything as automated as possible. In a traditional environment, we have the concept of a security runbook. Okay? It's your operational task list of what you need to do. If A happens, here's the steps you need to take. In the AWS cloud, that runbook should almost always be essentially an automated script or application running somewhere. Okay? You'll still have some manual checks, but you want to automate as much of this as possible because everything's accessible to you via an API call. And whether you're comfortable programming it or not, you can use the command line instead. Most of us in security, even if we're not used to writing code, we can run a CLI. They just launched V2 of the AWS CLI yesterday in a session. It's just getting better. It's in an exact mirror of the API call. It's just in a little easier way to consume, right? And you can take all of your CLI commands and put them in a script and run that, or have AWS run that for you. So what we have is we have some sort of trigger and a result. What we can use is CloudWatch events to Lambda to get that. So a trigger is the CloudWatch events and then Lambda, or we could use CloudTrail to Lambda to result. And that actually gives us a fast lane and a slow lane. So this is where that delivery time for CloudTrail really comes into play. We know it's 2 to 4 minutes. For CloudWatch events, it's sub-second, right? So normally you can count on 2 to 4 seconds, kind of, depending on how busy things are. But it's near time, almost instantaneous for CloudWatch events, which means we can do response for CloudWatch events. So let me give you a really, really simple example. And I'll just tell you this audibly because I don't have it on a slide. But if you had an EC2 instance and you were running some sort of security control, like let's just say anti-malware on it, and it detected a piece of malware was dropped on that instance. If it fires an event off, right, so you could send something to SNS, which is an event stream, you could catch that with CloudWatch events. And then you could use a Lambda function, which is our code running, take you 2 lines to change the security group on the instance. So you would have a security event. Within 2 seconds, you would have locked that system off so that it couldn't spread. No human required. That's extremely difficult to do in a traditional environment. In the AWS cloud, it's 2 to 3 lines of code and a couple clicks. And then you as a security team can respond afterwards, but you know you've stopped the attack, if it was an attack or issue, right in place. There's a whole bunch of stuff you can expand across that. And if you look at the slow lane with CloudTrail, that's not possible because it's 2 to 4 minutes later. So where CloudTrail is useful is in the scenario where if you have somebody logging into your production systems, you can't turn that off overnight. You will have a revolt if you tell people they can no longer log into production. But what a really cool thing to do is capture that through CloudTrail, that people are logging in, and then fire off a message through Lambda. Pop up in Slack and say, hey, you probably shouldn't do that. Try not to log into production. In fact, I talked with an organization who had set that workflow up, where what they used was Slack was a verification. And they said, Mark, did you log into this system? Yes or no? And if I said no, they would fire off a security incident immediately because they detected a login, and then they asked the person who had purported to be logged in, said, was that really you? No, it wasn't. Well, then it was somebody pretending to be you, which is bad. And if I said yes, it would then say, well, you really shouldn't do that, right? And that was a very simple automation again. We in security have really hesitated, or I shouldn't say hesitated. There have been a number of factors that have made it difficult to automate, one of them being our own hesitation. But in general, in the really diverse and complicated environments, it's hard to automate a lot of this stuff. With IAM integrated into everything in the AWS cloud, with everything available through an API endpoint, with the CLI there for us, even if we're not comfortable coding, we should be automating every single task we do from security, right? Lambda for cost bills by the 100 milliseconds of execution time, and it's 0.000002 cents per execution. Like, it is nothing. It costs almost nothing to run Lambdas, right? Which is awesome because the security stuff is always super fast, so it's really low cost, and it keeps you focused on what's really important. So we've asked a bunch of questions. We've seen sort of the broad overview. The goal here at the 200 levels is to give you the view of what's going on. So I hope that you can take this away that the cloud gives you the possibility to really simplify security. It does not have to be complicated. It starts with a shared responsibility model. If you understand that, if you understand that line, that you are responsible always for data, always for service configuration, sometimes for the application, sometimes for the OS. Our goal, make sure that our systems work as intended, only as intended. Our number one threat to that goal is mistakes, but we've got a bunch of AWS services that are available to us for low to no cost to help us prevent mistakes. So we have a plan. We can build one from the Cloud Adoption Framework. Those 6 perspectives help us engage stakeholders. They help us map out processes, see how technology is going to change, find the gaps and address them, build out a plan. We can start to build well using the well-architected framework. We can pick systems over people. That's picking the right controls and tools. We saw some of them in the presentation today. And then observing and reacting, using what we talked about observability and traceability, using that fast path with CloudWatch events and Lambda, the slow path with CloudTrail and Lambda, in order to not just set it up, but to continue to adjust as things react. These are the keys to building a successful security practice in AWS. It does not have to be difficult. Obviously, we can keep going down the rabbit hole once you've got this in place, but if you put this kind of stuff in place, you're going to hit 90-95% of most people's security issues right out of the gate with little to no investment, with integrating into the rest of your build team. It does not have to be hard. As I said at the start, this was a sponsored session. If you actually want to know what we do, because I didn't mention anything about us, which I prefer, we are in the Venetian at 2820. We do security for AWS. Appreciate your time. Thank you very much. If you want to follow me on Twitter, @MarkNCA, I put a link to the slides, should go out in a few minutes. Always happy to answer any questions around AWS, security, anything like that. Please remember, not just for this session, but for every session you attend, to fill in the evaluation in the mobile app. If you do at least one evaluation, you can go to the swag desk and get a pin, a special one for evaluation. I'm not sure what it is, but I'm sure it's interesting because I'm not sure what would visually represent an evaluation. But it does also help us plan reInvent for next year. Figures out what room to go in, who to call back, all that kind of stuff. So thank you very much. You guys have a great day. Appreciate it.